Kia ora, I'm Simon, R&D Solutions Manager here at Road Science. A lot of you will be aware that the NZTA has released the new M1-A 2019 specification for performance graded asphalt binders. Today we're going to take a look at this spec, help you understand what it all means and to help you get your head around how to name the new binders. So let's head down to the lab. First, let's start with the old M1 spec. For a few decades now, the names for the grades of the binder were based on their hardness values from the penetration test, such as 40, 50, 60, 70, etc. In the penetration test, you take a tin of bitumen that's been cooled to 25 degrees and you let this needle with a set weight on it fall into the bitumen for 5 seconds. The results it gives are in tenths of a millimetre. So for a 60-70 bitumen, that means the needle will penetrate 6 to 7 millimetres into the bitumen, and for a 180-200 it will penetrate 18 to 20 mils into the bitumen. This test has served its purpose over the years, but in reality it doesn't tell you much about the behaviour of the binder. It only gives you a generic hardness value at 25 degrees. It's a bit like thinking New Zealand looks like this all year round in every region. Binders behave very differently at different temperatures. Take these two for example. At 25 degrees they both feel pretty similar, but apply a bit of heat and we have a whole different story. You can now clearly see one of the benefits of using a modified binder in high temperature areas. It's clearly not apples with apples anymore. But don't worry, this is where the new M1-A spec comes to the rescue. It's a complete overhaul of how bitumen is graded and used. It looks at how a binder actually performs at both the hot and cold extremes of temperatures. Instead of New Zealand looking like this, it now looks like this. All the regions have been assigned a climate category of cool, moderate or warm based on their average temperature data. So what sort of temperatures are we talking about here? So as you can imagine, the actual maximum temperature on the pavement can get a lot hotter than the air temperature due to heat being absorbed into the dark surface. So for a cool climate, and some of this is less than 52 degrees, a moderate between 52 and 58 degrees, and for warm, 58 to a massive 64 degrees. Now you can start to see why testing at 25 degrees was never going to help us out too much. You will note that the M1-A spec doesn't actually have any test specifications itself. That's because it's been prepared as a supplement to an existing American standard called AASHTO M332. It's this document that has all the allowable test limits. So what are our binders called? Based on the AASHTO M332, these are our binders. So let's dissect that. PG stands for performance grade. The 52, 58 and 64 are the maximum average pavement temperatures, and the 16 relates to the minimum average pavement temperature of minus 16 degrees. So to use the AASHTO M332 spec, you first find your climate zone from the map for the area you're paving, then you get the binder grade from the table. It's this grade you use to help you get the specs. So take a PG64-16 as an example. You select the section with the PG64 and then the column with the 16, then you move down that column to get your specs. Certain tests have different specs depending on the traffic category, which I'll talk about shortly. These are broken down in the left part of the table. It can be a bit hard to get your head around reading this table, as the specs themselves are either written in the left column for some of the tests or the centre part for others. A lot of these central numbers are actually temperature conditions required for the test and not the specs themselves. NZTA has made it easier for us and standardised the minimum temperature as always greater than minus 16 for all regions. So you're always going to follow down one of the columns with the 16 in it. As this minimum temperature is always greater than the minus 16, let's not bother referring to that in the name anymore. So we have PG52, PG58 and PG64. Sweet. So we've covered off the effects of heat on a binder's ability to withstand deformation and how we name it. The next biggest thing that will kill a pavement is the traffic. How many and how fast are they going? The old M1 had no reference to traffic volumes or speed at all. It wasn't until you got to other specs like the M10 asphalt spec that was any reference to traffic. Even then, that was only a guide. There was still a large risk of binders being specified for a contract that had no chance of surviving the amount of traffic they're being subjected to. There are 4 binder grade categories based on the type of traffic. And these are standard, heavy, very heavy and extreme. M1-A gets you to combine traffic volume, speed and where the mix is placed to come up with one of these categories. This category is also used to determine some of the specs in the AASHTO M332 table as shown before. The team who put together the spec have included a super handy flowchart to pick the binder grade category rather than having to use the table. What you will notice is that when traffic is moving slower, the binder category bumps up to the next hardest level. Why is that? How does speed affect how a binder behaves? So bitumen is viscoelastic, which means as a material it behaves both elastically and viscously to different degrees at different temperatures when a force acts upon it. When something is fully elastic, when an applied force is removed, it will return back to where it started. When it is viscous, the material changes shape for good. Bitumen is somewhere in between both of these. Where exactly depends on temperature and speed. We've already seen how heat shifts bitumen from one end of the spectrum to the other. Loading on a pavement from standing or slow moving vehicles has the same effect as heat. That's why it's so important and why it's part of the decision making process. When it is slow loaded, it behaves more as a viscous material, like when it's hot, and can potentially rut or shove. Here's the same two binders from before, where at 25 degrees they both felt pretty similar. The straight run binder doesn't stand much chance, but again, as with the heat example, the modified binder's performance is miles ahead. But let's also look at the effect when bitumen is fast loaded. Come check this out. And when the same binder is fast loaded, it acts a lot more elastically, much like when it's cooler and can stand up to a lot more load. So now the spec has you covered for the two main factors that can contribute to the failure of a pavement: temperature and traffic. It will take a bit of time to adjust from the old penetration grade names to the new performance grade names, as it's a very different structure to get used to. Here's a rough guide how the current pen binders would fall into the different M1-A grades. You can see that with moderate and warm climates, once you get into the very heavy and extreme categories, you'll need to be using a modified binder. So now we have all the components needed to order your binder and a bit of an understanding behind each of them. PG for performance grade, plus the climate zone, plus the binder grade category. For example, PG64H. Keep at it, keep referring to the spec to help you out, as this is a really good move forward in the correct use of binder and asphalt pavements. Thank you guys for watching. We'll see you all in the next episode of Technically Speaking.